Check, check, check. Hey. Hey, okay. Okay, so let's get started with the stats, chapter 12. Happy
Jake.
Okay, let's just take a look at the back here. I'm going to start with the next set of questions refer to the following situation. So we're in the back side. Oh, actually, we'll just use these in order, 1, 2, 3, 4, 5. So two categorical variables, A and B, are thought to be related. Survey was taken and the results are shown below. What kind of chi-square test would be most appropriate for this? How many degrees of freedom? Okay, so for number 1, this looks like a chi-square test for either association or independence. Because my last one. Oh no, there's one here. The idea here is that we're trying to see if these two are actually related, which should translate to if they're related, that means that there's an association between them. So association and independence really are kind of the same thing. So that's what we're doing. How many degrees of freedom? So remember, degrees of freedom equals row total, number of rows, minus 1, multiplied by the number of columns, minus 1. Which in our case is going to be equal to, I don't know, 6. Which is going to be equal to 6.
Does it ever matter how you set up your chart with like which ones are rows and which ones are columns?
Technically, no, it doesn't matter. Create a table of expected values. Okay, so from here on, we're going to be looking at our program, and we're going to just start filling in the things appropriately. So we'll have to put everything in our matrix. So we'll go to our matrix command here. We're going to go to edit. Yeah.
Are we not using lists at all for this chapter?
You can use. You're going to be using lists for the goodness of fit. You'll see that in problem 1.
Okay.
So this is 3 rows by 4 columns. 3 by 4. Not 34. 3 by 4. And what is that? 12, 13, 34, and 25. What happened? $12. Hello. Enter. 12, 13, 34, 25, 19, 25, 28, 28, 28, 29, 14, and 15. So there does seem to be some kind of, well, it's kind of hard to tell actually. Okay, once you have them in your matrix, of course, quit to your home screen. Maybe push clear, so start with a clear screen. And we're using a program called Cells. Such a nice program. So this data right here, that's going to give us a few of the answers to the questions. So the first question it's going to answer is, what is the value of the chi-square test statistic? And that's right here, 24.687. 24.687. So that's the answer to question number 3. Chi-square 24.687. Okay. Next one, create a table of expected values. Okay, so let's make a table here. We got A1, A2, A3, A4. Got B1, B2, and B3. I think for here, we're just going to do some modeling. So we'll do this 12, 13, 34, and 25. And we'll be putting our expected values in parentheses afterwards. So that 19, 25, 28, 28, 28, 29, 14, 15. And you don't have to compute them by hand necessarily unless it's just one cell. But you can go ahead and, let's see, where are we? We're going to look at our matrix of expected values, which is in the appropriately lettered E. I think it's a lot easier to look at this if you go to the edit, though, rather than look at names. So easier for me if I go to edit. So let's look at that. Not quite what you expected most of the time. Those values are definitely a little bit different. So for the 18.4, 20.8. Actually, let's just use the power of computing here. 18.4, 20.8, 23.6. Yeah, I think at this point, if we're just, because we're not doing any calculations with these numbers, we're just, using them. 21.9. And what is that? 24.8. 24.1. And 25.2. 18.8. 21.3. 24.2. And lastly, 21.7. Oops. Oops. Okay. Yeah.
Is it association and homogeneity, are they listed on this?
No. They're the same kind of test or the exact same test, but the consequences of those tests are a little different. No, that's not what I wanted to do. How do I center a cell, the columns? Let's see, center. Or not. There we go. Okay, so I think that's good modeling here, showing us the table of expected values and giving us, or as they would be in an actual table, okay? Questions?
When we just update the table of expected values, we also supposed to include the observed.
As long as you actually have the expected values there, in parentheses is usually the way it goes. Yeah.
The F matrix one?
The F matrix we're going to use for question 4.
Oh.
So for question 4, it asks you, which cell contributes the most to the chi-square test statistic? Okay. So if you take a look, let's go back to the calculator, and if we take a look at matrix F now, again, it's easier to go edit. When you look at matrix F, these are the contributions of each individual cell to the chi-square test statistic. So in other words, for the very first cell, 1, 1, and this is going to be 12 minus the expected value squared divided by the expected value. This cell right here is 13 minus the expected value squared divided by the expected value. And the idea here is you're supposed to find out the one that contributes the most. Be a little bit careful here. I'm looking at these and I'm seeing this 7.8. So I can see somebody with rushing and looking at that 7.8 and saying, ah, this is the one. But that doesn't say 7.8, that says 7.1, 7.8 e negative 4. So that's 0.0007. Not quite the biggest. So what is the biggest one here? This guy right up here? Yeah.
The answer is both.
Yeah. So yeah, that gives us A3B1 and A1B3.
We only have to list one of them, right? Whichever one you choose.
Well, it asks for which one is the most.
And then they claim that they were both contributing the same. Maybe they're just doing like the 4.5 instead of.
I think because they just rounded up 4 point. They truncate
It's
it
around
at
it.
4.5. Also,
So both what is that, A3B1? A1B3? Thank you. Contribute 4.5 to the chi-square.
is that a direct function of the difference between expected and actual?
No, well, yes. But not just the difference. It also has to depend on what is the expected value.
So it was just a coincidence that those two happen to be the ones that
Yeah.
have.
Do we have to do both?
But depending on how you round it. I'm pretty sure that if you were just giving, let's see, if you had just given A3B1, you would have been just fine. Okay. Okay, so that takes care of questions 1 through 4. As you probably have noticed, there really isn't a lot of work to show on a lot of these problems. There's not a whole lot to do, really. Just, what is it? Okay, let's see question 5. Under a suitable null hypothesis, the expected frequency for the cell corresponding to fatal accident and small automobile size. Wow. I think that's looking at row 2, column 2.
That's right.
Row 2, column 2. So we're looking at row 2, column 2.
No one ever was being small.
Row 2, column 2. Why is it out of order? So that you're reading. Expected value, or no, the expected value, right?
Yeah.
Expected value is going to be equal to, what is it, observed minus, row total times column total divided by grand total. So in our case, that's going to be equal to, what's our row total?
1 division,
And our column total?
89. Oh, my bad, 223.
Which one?
223.
223. And our grand total?
374.
374. Boom. Expected value is 81. Okay,
It's a murderer.
6. By the way, that's a very typical. If someone doesn't want you to put the entire thing in the calculator, they would give you a question like this. They would probably leave out a couple of cells here and there too.
Can't you just open it in there?
Well, not if you're missing some cells.
That's right.
Yeah.
But you're not missing cells.
If you were missing cells, I could very easily imagine making a question like that.
Oh, geez.
Wait, how do you listen to those lineups, the total of the row?
Yeah, that would be very easy to solve.
What if you have 4 cells in the row, 4 columns, and you're missing 2, and you're missing the column total?
And then you still have the
Yeah.
total. Yeah.
It's possible to do it. You can engineer that question.
Yeah.
6, appropriate null and alternative hypothesis. So null hypothesis, there is no association between death frequency, death, there's a capital D, wow, that's final, death and automobile size. Okay. And alternatively, an association exists between death and automobile size. That's great.
So what we made in this case would be if the same death occurs in the same rate across all different sides of the arm.
Yeah. Which is really the same question, just kind of told in a different way.
It's like you're kind of looking at it opposite.
Yeah. All right, which of the following is the smallest chi-square frequency that would reject the null hypothesis at the 0.5 level? Okay, so this question is kind of a couple of things. First of all, we got to figure out our degree of freedom. And it is 2. So the quickest, not the quickest way, but a way to do this is to figure out all of the p-values. Okay, so we're going to start with 3.84. Oh, these are all in order, right? So start with the smallest one. And that's going to be the probability that chi-square greater than what's our number here? 3.84? Yeah, degree of freedom 2. So let's figure that out now. Distribution, chi-square CDF is 8. Oh, no, that's not what I want to do. I do not want to put that in the matrix. Chi-square CDF, yes. Lower in this case is going to be 3.84. Upper is always E99. Degree of freedom is 2, right? All right, so let's figure this one out. This one is 0.1466. 66. Fail to reject. Okay. The next one is 599. Let's just figure that out. 599. Let's just change that to 599. I wonder if that saves time. It probably does. Ooh, so close. 0500. Yeah, so that's really close, but it is fail to reject. So it should be the next one.
If it's the same, you can't reject it.
Nope. So the next one is 781. And let's just do that. Oh, that's not what I wanted to do. 781. 0201. That's going to be reject. So the correct answer is 7.81.
Do you want to just write that as the answer after you calculated that, or should you have shown that the p-value or 384 is this? Or
Well, do you want me to think that you just looked at someone else's paper or not? I mean, if you ever just write a number, that's I think that's never appropriate, right? Is the smallest test statistic that will be rejected among the choices. Okay, at the very end here, we're supposed to figure out a test statistic, and if you take a look over at the chart again, they actually give you a value of chi-square of 8.663. So you don't have to put this whole thing in your chart. You could just calculate that chi-square test statistic here. Let's calculate it. Plus u, 8663, 8.66. Where's my 8.663? Great. That gives me a p-value of 0.0131.
So number 7 was completely unrelated to the rest of the question, right?
Zero.
You have to use it from the manuals and
Oh, yeah.
that's how they go.
Gotcha.
Wow. Yeah.
I think we use the chi-square given in the program for cells, the 24.6873.
You should be able to. You should be able to. Is it different? Let's do this on. Let's see what happens.
Oh, so it's the expected value?
Yeah, let's do this. 2 by 3, right? 2 by 3, and let's put in these values: 63, 128, 128, and you said 46, right?
Yeah.
Okay. 26, 95, and 16. And let's run the program and see if we get similar answers here. We should. We should get the same
Yeah.
chi-square test statistic. Yeah, we do get the same thing. Okay. But if you read the chart, you should. I think it saves a little bit of time. Not that this is particularly difficult to do, but There is that.
Those are
No. Remember, that's the thing with these charts. They give you all sorts of crap. Excuse me. You didn't hear that. All sorts of information which are extraneous. So you need to be able to filter through the extraneous information to figure out which exactly you need and which information you don't need. So that's exciting. I remember this problem. Okay, that's 1 through 8. Problem 1, shall we? What's problem 1? Problem 1. Okay, drivers born under the astrological sign of Capricorn are the worst drivers in Australia, according to an article that appeared in the Australian newspaper The Mercury in 1998, October 26. The statement was based on a study of insurance claims that resulted in the following data for male policyholders in a large insurance company. The number of policyholders. Why does that mean they're worse drivers if there's more policyholders? Why do they make that association? I don't know. Let's see. Enter the expected counts under the observed counts. Gosh, I'm making this chart. It's going to take forever. Maybe I should just open it and copy and paste. Oh, it's open already. Nice. Boom. Love it. This is OneNote, yes. It's better than you think it would be. Not high praise? I think it's pretty good, right?
Better than you think it would be. Like, use something that would be good.
It's a Microsoft product. Why would you think it's going to be good?
Well, Microsoft hasn't done anything good since XP.
Yeah.
XP came out after 98. God damn, I knew it. God damn. XP came out in 2003.
I don't know the release dates for all of the Microsoft products. I'm sorry.
Well, 98 is pretty straightforward.
That's true. But XP?
95 though.
I have no idea. Okay, so we really should get this done. Let's put our now this is going to be a goodness of fit test. So this is not in the matrix. These are in the lists. So we need to edit our lists. So someone want to do the honors of reading all these insanely large numbers?
Sophie, go.
Sophie, go.
Okay, 37,926. 37,179. 37,179. 38,126. 37,354. 37,718. 37,910.
How are you reading these with so much emotion?
35,352. 34,175. 54,906.
That's absurd. That's crazy. No.
Oh, number 10.
54,906. 35,666.
666.
36,677.
Great. Okay, so we're under the assumption that the number of policyholders are supposed to be uniform for all of the astrological signs, right? Somehow. So we're going to have to figure out how many people hold policies. So if you remember, that's the sum command, which is under list math, number 5. We want to take a sum of list 1. That is that 460,000 number. And then we want to distribute that equally
Wait, where do we get? Where do we get the sum?
Second stat.
See.
I'm sorry, you're yeah. Second stat math. I think it's 5. And then yours is going to be under the stat list editor. I think there's a math menu.
Yeah, you go to F4, count, and then the one big stat.
Or you could do that, yes.
Oh.
Oh,
Oh, well, math works too, yeah.
You could do that too.
do we usually get this into a list? There's some.
Yeah. I think that's the most expedient way to do it. All right, divide that by 12. That's going to give us our expected value. 23, 230, and 230,084.
Divided by 2.
Oh, wow. So that's not going to work. Divide by 6.
Divide by 12, we get 24.
Damn it, Ophir. 38, 347. What I'm going to do is I don't know, I'm going to store this number just so I don't have to keep typing the number over and over again. I'm going to store it as A. I'll go back to that and I'm going to the list and I'm going to make all of these the same number. That number is A.
Would you store it?
I stored it as A. You can store it as anything you want.
Yeah.
That's just my attempt at shortcut. What just happened?
We divided
I missed how.
for all values.
Yeah. Because remember, all the zodiac signs are supposed to have the same value. If there's no association, and they should have the same value.
Even if you found an association, can't you conclude that's
You can't conclude that it is because of the worst drivers, but you just conclude that there is some kind of association.
So, do statisticians ever like take a hard stand on anything? Yeah, you know, it's kind of like a blank.
No.
Maybe.
No. I don't think it's a statistician's job necessarily to do that. You know, provide evidence, say what the evidence most likely means, but let some other idiot like draw out the conclusions. You know, exactly. Jeffrey Brown, yes, of course. Okay, so what are we supposed to say? What do they expect? Enter in the expected counts. And I think we're just going to say for part A, all the expected counts are, and I forgot that number again.
38347.
Yeah, that's good enough. Of course, if you were taking a test and it tells you to write it underneath each value, then you should write the same value underneath each observed count. B, write a null and alternative hypothesis for a chi-square analysis of the data. So, null hypothesis. The number of policyholders for each astrological sign is the same. 38. Yeah, it's just the number of policyholders, right?
So maybe Capricorn drivers are just the most common.
0.3.
No.
HA,
Maybe most people just calculate the
um, and you know what we should also say here is proportion. Equally good would be the portion. Proportion of policyholders for each astrological sign is 1/12. That would be saying the same thing, but using proportions instead of counts. Okay, so at least one astrological sign differs from the expected count, or of course, at least one astrological sign differs from the expected proportion. And of these, I think the proportion one's probably the better one to use. Would probably pick this one if I had to pick one for you. Questions on B? Okay. Let's take a look at C. Copyright. Okay, so there are only two conditions that need to be met. That first condition is about random sampling. So are we told anywhere that this is a random sample? We're not, are we? No, it says to assume that this is a random sample, right? Okay. We are told to assume sample is a random sample. We'll take this to mean simple random sample. Remember, it is supposed to be a simple random sample. Other random samples are not technically to be used. Must be a simple random sample. And then all the expected counts are 3,000, I forgot what the number is, 38,347.3, which is greater than 5. Those are the only two conditions that need to be met. Just barely bigger than 5,000 times 6. Plus another 5,000. Okay. Test statistic, degree of freedom, p-value. Yes, we can finally use our calculator for what it's intended. Okay, let's get to our program. And the correct program here is what, goodness of fit or GOF or whatever it is. Do I have GOF? I do have GOF. Goodness of fit, boom. Observed is in L1. Expected is in L2. Yeah. 8,216. P-value is 0. I mean, you know, look at a chi-square 8,000. Jeez. It's kind of hard to
But like, is it analogous to something we did with like CDF and?
Yeah, that's analogous to like T or Z, a Z score or T score.
Okay, so it's like we had the Z score that was 8,000.
Yeah.
That's okay. When this period, what was the observed value for the in the system test?
The observed values for all 3,000
Oh,
or 34,000 or something. Okay, test statistic chi-square is equal to 8,000 something. What is it? 216. Next is the degree of freedom. Degree of freedom is equal to 11. And the p-value is 0. Good. And awesome. Okay. Perfect. Questions on D? Bless you. E, make a decision. So our decision, ooh, euro. Ooh, euro. Our decision is going to be to reject the null hypothesis. Reject the null hypothesis. Conclusion. Let me see if I can remember the phrase that pays. Was it assuming or if the null hypothesis is true? Is true. There is a 0% chance of
obtaining a chi-square statistic least as extreme as the one with
8,216. The data supports what's our hypothesis that at least one astrological sign differs in its proportion from 1/12. I think you have to go to list 3 and make it equal to the contribution list. So I think we should do that now. So if we go to stat, edit, we can go to the top of L3 and make that equal to list contribution number 7. When we do that, we'll see the contributions of each chi-square test statistic. It shouldn't be surprising that the Capricorn contributes the most to the chi-square test statistic by a large margin, 7,000. Technically doesn't matter, but list 3 would be the easiest to view.
No, but list 3, like, how did you? Wait, I think it should come up.
List names.
Second.
And then contrib 7.
Oh, I don't have that.
Did you run the Goff test? Did you do the Goff program?
I couldn't get it. It said error. Mine. I don't know why. Okay, I can't
Check the list that you're putting into it. It won't. You can only do contributions after you run the Goff program.
Alright.
So you go back to the conclusion.
Did I do it?
Am I missing anything?
No, just go ahead, run the program.
Alright, run program.
The-
God. And the observed is the answer.
No,
I put in the actual thing.
go ahead again.
Okay.
Goff. Your observed was in list one. So put in list one.
Oh. Or
List one.
this one?
L1. Okay. Where did you put your expected?
Oh, okay, okay. I see what you mean.
Two.
Yeah, yeah.
Mhm. Now you should get a contribution list.
Okay.
Okay, that's kind of it. I think we're gonna have to do problems 2 and problem 3.
Okay.
Look how uneven this is. It says problem 2 is spelled written out, and then 3 is a number 3. My English teacher would be embarrassed. I'm sorry, Ms. Lobb. Yeah, I've had. She was the sweetest woman. I miss her.
Where is she?
I don't know. She retired shortly after I graduated.
So bad.
I really miss her. She was so lovely. Lovely lady.
That sounds very confident.
Really? No, she was lovely.
Oh, Fear, you didn't interact with him ever because you didn't.